Bismillah ar-Rahman ar-Rahim. Hello everyone. This video we're going to go the project phase 2 report. So the phase 2 requirements, you should submit a report of your findings inside that report. Don't just do the analysis on RStudio and just copy paste them and throw everything inside a Word file and send it to us. You'll not get a lot of grades like this. You have to write something that's nice, like this report here. So your phase 2 report should include at least the following: description of the dataset. What is this dataset used for? How did you get it? What is your target population? So you have to describe your dataset. If it's dataset about the cars and their prices and makes, say so. And usually you will find some of this description online on the website that you got your data from. What is it used for? What do you want to do with this dataset? How did you get it? The source of the dataset. If you got it online, please put the link and at the time that you access this link. And what's your target population? For example, if this dataset is about the cars in USA, so the target population will be all the cars inside the USA. So it depends on your dataset. After writing this brief introduction, you have to do quantitative statistics and then categorical or qualitative statistics. Remember that we need you to have your group to have 5 variables, 3 of which are numerical and 2 of which are categorical. For each of the numeric variables, you will do the following on RStudio. You will calculate the mean, you will calculate the standard deviation, you will calculate the 5-number summary, and then you will graph a suitable graph box plot and histogram. Then you have to comment on everything. So description of the center, shape, and spreadness of the distribution. This is from the histogram. You can define outliers if present. This is from the box plot, or you can define outliers as well from lower fence and upper fence. Then comment on all of the above findings. You have to comment on everything that you got. This is for each and every one of the numeric variables. For the categorical variables, you will have two qualitative or categorical variables. For each of them, you have to find the proportions, percentage of each category. For example, if I have a variable named gender, so I want to find how much are the females and how much are the males. Is my sample 50-50, or is it 30 males and 70 females, or 30 females and 70 males, and so on? Then we want you to find cross tabulation of the two categorical variables. So we want you to make a two-way table, like have the gender here and profession here, or marital status here. So, and find the joint frequencies. So it's a two-way table where the joint frequencies are there. This is the cross tabulation. And finally, for each of the two variables, you have to graph a bar chart and a pie chart. And as usual, comment on all the above findings. After doing this, so the first thing is the introduction of the data, quantitative statistics on R and comments, categorical statistics on R and comments. Finally, we write a final, like a paragraph or two, summarize everything you got. So here you will be commenting on the quantitative data, and here you will be commenting on the categorical data. Here, I want you to write a paragraph summarizing the characteristics of your data set. So you will describe the whole data set from your findings in the quantitative and the categorical sections. And finally, you have to write some suggestions, like how your dataset can be used for further analysis from your findings. You may suggest what you plan to do for the next phases, or what others can do with this data. For example, you may suggest how you're gonna do regression in the next phase and correlation relation between the variables, which numeric variables affect which, and so on. So this is a suggestions board, and you will find here the grade distribution. The introduction, you will be getting 10 marks for it. Quantitative statistics on R, 35 marks, including the comments. This is not only for the calculations and output. Categorical statistics, 30 marks. The summary, 10 marks. And finally, suggestions, 5 marks. These add up to 90. Then we have the last 10 will be 5 for free of spelling errors. If your report is written nicely without any spelling errors, you will get 5 marks. And it must be written in a nice way with no plagiarism, no AI generated text. This will also give you other 5 marks. Okay, so let's go through R. see how we're gonna do the analysis, I prepared an example file for you. So first thing, how do I open a script file to write my commands like I did here? You will go to this arrow here. It's called new file. You will click on this arrow and then choose R script. This will open a file where you can write your codes of commands here. You can write codes of commands. These will run if I try to write them, if they are meaningful, of course. If I want to add something like a comment here, مثلا for example, this line here, it's not a code of line, it's a comment. So I want to tell R that this is a comment, do not run it. So I will just add a hashtag before it. You can add however many hashtags you want. Okay, and then you can add hashtag here if you want a multi-line code and so on. Okay, so this is how you open a script file to write your codes. Second thing, I want to teach you how to open the file and load the dataset inside R. So once you downloaded your file, it will be either in Excel format, .xlsx, or it will be in .csv format, comma separated values. So to load either this or that, I will show you how to do both. So you will click on file here, top, then import dataset. Then you will have several options here. These are the two options we want. From text read R, this will open CSV files. Your file is saved as CSV. And from Excel, this will open your .xlsx file, or Excel format files. So my file is saved as Excel format, so I will just go through here. So once I click on Excel format, it will open this menu for me. So I will click on browse and look for my file. So I have this Park example file here. I will double click on it. As you can see, there is a preview of the dataset here. And there is also a code preview in the top right corner here. You can copy it from this sheet. Once you click on this, it's gonna be copied. Why do I need to copy this? Let's import the dataset first. So I loaded the dataset and I clicked on import. Here, after loading the dataset, click on import. So as you notice, the dataset is loaded now here in R. Why did I copy the command? Because I can add the command here, Control V, to add the command that are used to load my dataset, so I can load it more easily next time. So let me delete my dataset here to show you. Here I don't have the dataset anymore. So instead of going through file, import dataset from Excel and browsing and so on, I can just run this command, highlight it and click on run. This will load the dataset and open it here. So that's why we copy the code and add it here. Okay, so once Spark example is opened now, as you can see, it's like an Excel worksheet. I have the observations on the rows and I have the variables in the columns. So this data set, I have 5 observations and I have 50 rows. So sorry, 5 variables and 50 rows, 50 observations. You can close this now. And as you can see, it here also says that this data set has 50 observations of 5 variables. So this is how you open a data set. Right, now I closed the preview here. If you want to open the preview here again, you can either run this command, view park example, and this is park underscore example. The P is capital and the E is capital. Remember that R is a case sensitive language. So if this is capital, it must be capital. If this is small, it must be small for the command to run without any problems. Okay. And this view here, it's V capital as well. So don't make it small. Like you can either run view park example and it will open it here, or you can click on the data frame from the environment. So if I click on it, it's gonna open it again from here as well. Okay, so this is if I click the dataset. If you click the blue arrow beside the dataset, it's gonna expand a menu, all the variables. So this dataset, it says 50 observations of 5 variables. So these are the 5 variables. So I have the ID variable, it's recorded as 1, 2, 3, 4, and so on, up to 50. Then I have the age variable. This is a numeric variable, as you can see, R reads it as num. It records the age of the people. So the first person has age 50, the second person has 14, and so on. Then the activity, what was the person doing in the park? And as you can see, R here recorded this as a character variable. Character means a string, so it's a qualitative variable. And gender is also a character variable. And finally, duration of visit per hour or in hours. This is a numeric variable. So these are the 5 variables I have. Like, do analysis on these variables. It's a little bit not practical to keep it inside the data frame like this. So I can take this variable, for example, this variable age outside of the data frame, so I can do analysis on it much easier. Let's see, what do I mean by this? For example, if I want to calculate the mean of the variable age, if I try to write mean, and this variable here is called age, A capital G E. So if I try to write in the console here, mean age, R will give me an error. It's gonna say object age not found because I don't have any object here. And let's close this. I don't have any object here called age. However, I have a variable inside this data frame called age. How to load this or how to find the mean of this? I will write it like this: mean. Then I will tell R to go to this data frame, Bark example, and RStudio helps you with this as it auto completes. So you can write bark underscore and it will auto complete by pressing tab. So now I'm telling R to find the mean of bark example, but I don't want to find the mean of bark example. I want to find the mean of the age. So I want to tell R to go inside this data frame and look for the variable age. So I will write $sign. This will allow me to choose which variable I want to find the mean for. So I want to find the age. So this is the command mean bark example data frame $sign to access the variable inside, and finally the variable age. So if I run this, it's gonna be 36.96. This is the mean of the variable age. Okay. However, this is not practical to write every time. It's not practical to keep writing every time bark underscore example $sign age, especially for example if I want to find the mean of bark example duration of visit. So I don't have to keep writing this every time to find the average of the duration of visit. So I can save this variable, the duration of visit. I can take it outside of this data frame and save it inside another object or another vector in R, so I can use it easily. So it's like as if I'm renaming it, but outside of the data frame. Right, to do this, let's do this for the variable age. So I have bark underscore example $sign age. This is the variable age. Do analysis on this every time. As we said, it's time consuming. So what can I do is I can create a new variable or a new age. You can give it any name. So let's say I will call it age. And then you will do a space, less than mark, minus space. This here is called assignment operator. I am telling R to assign whatever I write on the right side here and save it inside a new object called age that is on the left side. So this is the assignment operator. It has to be an arrow going to the left. Okay, so again, I will write age. This is the name of the object that I want to create. Space, less than, minus, space. So I'm telling R, take whatever on the right and save it to the new name on the left. So whatever on the right, what do I want to save here? I want to save this bark underscore example $sign age. So I will write bark underscore example $sign age. So notice what will happen here. A new variable popped up here. So this is a new object or a new variable. So it's the same as this one here, but outside of the data frame. So this variable age here, I cannot use it by itself, except for when I mentioned that it's inside this data frame. However, this one I can use it freely by itself. So now if I want to find the mean of the age, this was the old way we did it. And now the new way, faster way, is to write mean age. Okay. So I will do this for all the variables. So all the variables you have, just give them names. So I will call the ID small, the age small, activity small, and so on. Especially for this one, this is very annoying. It's duration, space, off, space, visit, space, hour. So I will just save it in a new variable called visit. So mark these and run them. course, you will be changing your data frame name and your variable name. This is just an example. Okay, so for the quantitative statistics, for each of the 3 numeric variables, do the following. You'll find the mean, you'll find the standard deviation, you'll find the 5-number summary, and then do suitable graphs. Like, first to find the mean, this is the function that we just did, mean of age. So mean of age is 36.96. But as you can see here, when I ran this command by itself, mean of age, it's displayed its value here, but it did not save it here on the right side under an environment tab. It was not saved here. So what if I need this mean age later on? For example, if I need it مثلا during the confidence interval or the hypothesis testing, inferential statistics, as we will see later on. So I can save it inside another variable. So let's say مثلا I will call it m of age. This means the mean of age. Okay. So I will tell R, take this function, the mean of age, and save it inside m underscore age. So if I did this, it's gonna create a new variable here called m underscore age, which stores the value of the mean. So we will be doing this for the rest, for the standard deviation and so on. So the standard deviation, the command is sdh. So sdh, this will display the value of the standard deviation, but it's not gonna save it here. So I will call it sd underscore age, then assignment operator sdh. This will store it here, so I can use it later. And the 5-number summary. The 5-number summary are the minimum, Q1, Q2, Q3, maximum. So I will create 5 new objects to store. Minimum age, Q1 age, Q2 age, Q3 age, maximum age. And these are the commands. To find the minimum, this is the command, the minimum age. So let's run this command. So minimum age here is 14. As you can see now, it's saved to the environment, but it did not display the final answer here. So if I want to display the final answer here, I'll just write the name of the variable. So it's gonna display it. So this is the minimum. This is the maximum. So now I have the minimum and the maximum. As for Q1, Q2, Q3, to find them, I'm gonna use a function called quantile. So the function here, quantile, I'm using the variable age by the way as an example. You can apply this for all of the numeric variables one by one. So the function quantile, it finds the percentile that you specify. So for example, if I want to find the 10th percentile, so I will write quantile age, then 10th percentile represents 10%, which is 0.10. This will give me the 10th percentile. Now, if I want to find Q1, we know that Q1 is the 25th percentile, and the median, which is Q2, is the 50th percentile, and finally Q3 is the 75th percentile. So I will use the function quantile age, comma 0.25 for Q1, 0.5 for median or Q2, 0.75 for Q3. So now we can mark all these 3 and run them together. And as you can see, they are saved here. All their values, I'll just write Q1 age, call its value, and so on. Okay, so this is a 5-number summary. So all these will be done for all the 3 numeric variables. Then to do suitable graphs, boxplot and histogram. The boxplot is done using a command called boxplot. Ironic, right? So boxplot age, let's ignore this option for now. So boxplot of the variable age. So let's run this and see what happens. So in the right bottom corner here, you'll find several tabs. This tab here can help you with a specific function. So for example, if you want to find help with the mean function, you just write mean and it will give you some examples how to do it in R and so on. And this is one of the most useful ones for us, the plots menu. So once you click the plots menu here, this will give you the history of all the plots. And as you can see, there are some arrows here that you can get the previous plot or the next plot. Of course, I have only one plot here, so I cannot navigate through them. But anyways, they are here if you have several plots. Like if you have the graph like this, you can just zoom it so you can check it better. So this is a box plot in vertical manner. We are used to a box plot in horizontal manner. So to draw a box plot in horizontal manner, I'll just go here inside the box plot function. After the name of the variable age, I will add this option, horizontal equal true. Let's run this now. As you can see, box plot turned horizontal. Now we can comment on this box plot. For example, this here, the difference between Q1 and Q2 is bigger than Q2 and Q3. So this means the data is skewed to the left. I don't have any stars or circles outside here. So this means that I don't have any outliers. So this is a box plot of the variable age. Like, let's see, this is an example of a box plot with outliers. This is a built-in dataset in R. It's called the Iris dataset. So let's draw it and see what happens. So this is the box plot of the Iris dataset. As you can see, the shape here is skewed to the right. And I have 3 outliers on the right side and 1 outlier on the left side. So the box plot can tell me about the shape of the distribution, whether it's symmetric, skewed to the right, skewed to the left, and it can tell me about the outliers as well. So this is the first graph box plot. The second box plot is HEST. So HEST will draw a histogram. So histogram of age, this is the default. So histogram of age, if you run it, it's gonna graph it like this. You can specify the number of classes if you want. So for example, if I want to graph this with 5 bars only, so I will add the option comma 5 inside the HEST function. So when I run this, it's gonna give me the histogram of 5 bars. Sometimes R will not do meaningless bars. For example, if I say histogram age 6, so R will just keep it as 5 because one of them are meaningless. Maybe it's empty, something like this. You can just leave it default, run it, or you can add 5 classes if you wish. So this is how to find the histogram. About the outliers, we said that we can detect outliers using the box plot method, or you can find the lower fence and the upper fence. So to find the lower fence, we need, or the upper fence, we need to find first the IQR, the interquartile range. Find the interquartile range of the variable. You just use the command IQR, everything capital. So IQR capital, and then add the variable inside. Then we can save it in a new variable. Let's call it IQR underscore age. So I can use it later on to find the lower fence and upper fence. Run this. Now I have IQR underscore age. Now to find the lower fence, we can write LF and upper fence is UF. LF of age. The rule of the lower fence is Q1 minus 1.5 IQR. So we will write it R like this. Q1 of the variable age. This is the one. It must be saved here that I saved already. Okay, don't forget that. Minus 1.5 IQR of the variable age. If we try to run this, you would see that there is an error. Unexpected sample. Why? Because R is like a baby. You need to tell R everything you're doing. So here I'm doing Q1 minus 1.5 multiplied by IQR. So I have to come here and tell R that I am multiplying by adding the asterisk. هنا 1.5 multiplying IQR. So when I run this, it's gonna give me the lower fence. The lower fence, it's negative 6.75. Then I can do the same, but with Q3, but Q3 plus 1.5 IQR, this will give me the upper fence. So now I have the lower fence and the upper fence. If the lower fence is lower than the minimum, then no outliers on the left side, which is the case here. The minimum here is 14, and the lower fence is negative 6.5. So this is 14. Negative 6.5 is on its left, so it's less than. So no outliers on this side. And for the upper fence, if it's greater than the maximum, then no outliers on the right side. So the maximum here is 58. And the upper fence that we found is 79. So it's greater than the maximum. So this means I don't have any outliers either side. This is for the quantitative statistics. For the qualitative statistics, remember that this will be done for each variable. For the qualitative statistics, first we need to find the proportion, the percentage of each category. Find the percentage, we need to find the frequency table and then the relative frequency table and so on. Type to find the frequency table of a variable. Let's remember here which variables I had that are categorical. I have activity and I have gender. Find a frequency table for the gender, for example. I will write the command table. So this is the function that we are going to use, table. And inside this table, write the name of the variable. So table gender. So this will tell me that I have 27 females and 23 males. I can do the same for the other variable activity. Okay. As you can see here, this table is just displayed in the console, but it's not saved here anywhere. So I need to save it for later use as well. So I will use activity as an example here. So I will get the table activity. This is the frequency table of the variable activity, and assign it inside a new object. Let's call it frequency underscore activity, or I will just call it f underscore activity. So this is saved here, as you can see. F act, this is a table, frequency table of these values. Okay, we can call it anytime here in the console, f underscore act. This will call it here, so I can display the frequency table at any time. So after finding the frequency table, I need to find the relative frequency table. So I will call it rf underscore act. To find the relative frequency table, change the names here. To find the relative frequency table, the relative frequency by definition is what is the frequency divided by the total, right? So this is, I want to find the whole table, the relative frequency. So I will take the frequency table that I just created and divide it by the total of this variable. You can find the total of the variable using two ways. You can either go here and check how many observations I have. So here I have 50. So I will just write divide by 50. Or if you don't know, or if you are lazy to look up for this, just write length of the variable activity. So what will R do here? R will go check the variable activity, how many observations I have in here, and it will find its length, which is 50. So it will find the relative frequency table. So let's run this command. So it's saved here. I will call it here rf underscore activity. So this here tells me that eating represents 0.32, playing 0.32, and walking 0.36. Now to find the proportion, we want to find the proportion or the percentage of each category. I will just take this rf underscore act and multiply it by 100 and save it in a new variable called prop underscore act, portion of activity. So now to display this proportion underscore activity, this is gonna display 32%, 32%, 36%. Okay. So this is the proportion for each category, and you'll do the same for second variable. So for example, the gender, I will do table gender. So this is a frequency table of the gender. If I want to save it, I will write f underscore gender, for example, then the assignment operator, table gender, it's gonna be saved here. Find the relative frequency of the gender. I'm gonna write a new name of the variable, rf underscore gend, assignment operator, f underscore gend, the frequency divided by the total. So the total here is the length of the variable gender. So now I have the frequency table and I have the relative frequency table of the variable gender. Now to find the proportion of the variable gender as well, I will just take the relative frequency that I just got and multiply it by 100. Then we can display it here. As you can see, I'm writing commands in the console here. You can write commands in the console for testing. And then at the end, you can just keep copying them, putting them back here inside the script. The script is what you will save. And this is going to save you every time. Instead of keep writing all the lines again, you'll just have them ready and you can just run them every time. Okay. So this is for the proportion and the frequency tables. Now we need to find the cross tabulation of the two categorical variables. So I know that table gender, this is the frequency table of the gender, and this is the frequency table of the variable activity. Now I need to find the cross tabulation of them both. The command is table gender activity. So table gender comma activity. This will give me a cross tabulation with gender on the rows and the activity on the columns, as you can see. So the first variable you specify will be on the rows. So for example, if I flipped them like this, activity, comma, gender, This is gonna look like this. However, it looks nicer to have the smaller category on the left side on the rows and the more categories on the right. So I have gender has 2 categories, so I will keep it on the row. Activity has 3 categories, so I will keep it on top. So this is the cross tabulation. We can always save it inside new variable. So I will call it مثلا cross underscore gent underscore activity assignment operator the contingency table. So I will just save it inside this object so I can use it at any time. This is a new object cross gender activity. I can use it at any time. Now, the suitable graphs is the last thing. Suitable graphs. We need to graph a bar chart and pie chart. Okay, to graph a bar chart and pie chart, you will notice that I wrote for you a comment here. Do not use the variables themselves, and instead use the frequency tables you created. Remember the frequency tables that we created here, the frequency act, frequency gender, proportion act, proportion gender. These are the ones that we are gonna be using. Why? Because let's see, if I try to graph a bar chart for the variable activity, for example, the command is bar plot. So I will write here bar plot of the variable activity and see what happens. It's gonna tell me none error, non numeric argument. And the same for bar plot gender. It's gonna tell me non numeric argument. So R cannot graph a bar chart or a pie chart for categorical variables directly. I have to find their frequency tables first. So now I will graph the bar plot for the variable f underscore act, the frequency table of the activity that I saved here. So as you can see, it appeared in the plots here, and here we can navigate the old histograms and box plots that we graphed. This is the history of the plots. So this is here the bar chart of this activity variable. You can also find the bar chart for the gender, f underscore gender that we saved. You must have saved it before. So this is a distribution of males and females inside this sample. So that's it for the bar chart. It's very easy and very straightforward. For the pie chart, it's also the same idea, but instead of using the frequency table, I will use the proportion table. So the command is pie proportion underscore activity. This is the one that I saved. So as you can see, when I ran this command, pie proportion activity, this is what appeared here. So I have these 3 categories: playing category, eating category, walking category. But since these are a bit close to each other, so I cannot specify how much percent exactly is this. So what if I want to display the percentage here? So I want, for example, to write eating is 32%, for example. Walking is 36%, something like this. So we're gonna be doing this command. So pie proportion underscore activity. This is just to graph the pie chart itself. I will add this option beside it, comma, labels equal, and inside this function, the option inside the pie function, I will write the following command. So labels here, labels mean the names on the pie chart. So I want to change these names, right? I don't just want them to be playing, eating, walking. I want playing is 32%, walking is 35% or 36, like this. So I want to write the labels equal, and here I will add this function. Type. Let's see what this function is about. This is the paste function. The paste function in R is your best friend's your best friend when you're talking about labeling graphs and so on. So this paste function will just display a string. So I want to display what? I want to display the name of each category. So how many categories inside this table I have? So prop underscore act. So I have eating category, I have playing category, and I have walking category, and this is the percentage of each. So I want to display the name and the percentage of each. So I will write inside the paste function names of portion underscore act, comma, then is, this is a string is. So to write any string, I'll just write it between quotes like this. And then proportion, comma, proportion act. This is the proportion by themselves, the 36, 32, 32. So let's do it step by step together. So if I just write it like this, paste the names of proportion activity, this will just again display the names only: playing, eating, walking. Moreover, I want to display is, so comma, quotes is. So if I run this, it's gonna, as you can see, it's playing is now. Now I want to display also the value of the proportion, so I will add the variable itself, the table that I saved, proportion underscore activity. Let's run it. As you can see now, it's playing is 32, eating is 32, 36. Now if I want to add also the percentage mark at the end, I will just add another string here, comma, string, and then add the percentage mark inside and run it. So as you can see, this is the final shape. Playing is 32%, eating is 32%, and walking is 36%. You'll just be creating your own tables. You'll just be replacing the names of the variables. The codes are here. You have all the codes. You'll just need to create your own variables and put the names here everywhere. Thank you, guys. If you have any questions, check the video once and twice, and feel free to send me at any time if you need any help with anything. Have a good night.